In this video, what I want to do is talk about the essentials of blockchain, what we need to know to really understand how Marlowe is built. So let's start off by just describing what a blockchain is. What we have is a collection of transactions, and what those transactions do is allow us to flow digital values from inputs to outputs. You can see that the inputs are labeled red here, the outputs in black. And an unspent transaction output, or what's called a UTXO, is the basis of the blockchain that underlies something like Bitcoin. There are other account-based blockchains, and Marlowe can work on those as well. But just to point out that Marlowe is designed to work on a relatively simple blockchain called a UTXO blockchain. The process you can see here of spending an output where it's connected to input of another transaction is called, that's the process of redeeming, and that process has to be validated by the person who, so that the person spending is the money is the person who indeed owns that money, owns that asset on the blockchain. So blockchain is this linking together of these transactions. So that's the basic principle. Now, the other aspect of blockchain is the fact that it's distributed. So we could simply ask, if we had a monk, for example, he could write down all the transactions that took place in the blockchain. That would give us, he would simply write things down. It would give us this irrevocable record of transactions. We'd write down, we'd know who owned things, what payments had been made from one person to another, and so on. But in order to do that, we have to trust the monk. We have to trust this central authority. So the question is there a way that we can, without a central authority, somehow distribute the integrity of this ledger? We can distribute it. We can share information. We can update accordingly, and as long as we realise that any distributed system does can potentially be vulnerable to partition of a network or whatever, we can build this robustness into the ledger by distributing it. But in that situation, we have to trust all the monks. We're assuming that they will all agree. But of course, we could have some participants. We could have participants who were actively hostile, who were trying to change the state of the world, change the state of the ledger, presumably to their benefit. Or we could have some people who just walk away. They think, well, why are we going to continue doing this? So we have to, when we're thinking about building a self-sustaining system like this, which has no central authority, we have to think about how we're going to ensure that it has, each of the monks in the end has the same view of of what's gone on, has the same view of the ledger, so that we have this consensus about who owns what. Now, what we do is as you can see here, we broadcast, if a transaction has been made, we broadcast that across the network. But then we have to think, well, how will that be secured? And I guess the key to this is there are two things going on here. In order to make sure that things are not changed, the history isn't rewritten, we use cryptography. I'm not going to talk about cryptography at all in these videos. Suffice it to say that we use cryptography to guarantee that secrets are kept. We can use it so that only with someone's private key can they spend a resource. And signing with a private key allows somebody to authenticate, allows them to make a signature of something. So we're able to keep things private. We're also able to authenticate that someone is who they say they are, using tools from cryptography. At the same time, if we want to ensure that people don't walk away, for example, if we want to shape how the future is, then we need to use incentives of some form. And I guess the thing that is at the heart of the Bitcoin model, and was the great achievement of Satoshi, was to see that there were ways that consensus could be achieved by allowing people to gain financially from, in the case of Bitcoin, mining, in the case of the Cardano blockchain, using a proportionality to the amount of stake someone has in the chain to reach a consensus as who decides the next block to go on the chain. So the blocks in the blockchain are collections of transactions, and these are at each round, somebody in the chain is identified as the person who will, somebody in the distributed system is identified as the person who has the consensus. This is either, as I say, through proof of work or proof of stake. And then they place the new block on the chain, and everybody else, all the other monks, all the other nodes in the system, will check the validity of the proposed new block. So there is that consensus there. So we have this model of blockchain. It is in the end, when we're thinking about the financial contract aspects of this, we don't need to think so much about the distributed nature, but we do need to concentrate on the fact that what we have is a ledger. It's irrefutable. So we use cryptography there to ensure that the transactions on the ledger are, once they're there, they can never be changed or removed. The blockchain itself checks that money is spent by the person who owns it, checks redemption and validation. But the blockchain is a passive thing. It's a ledger in which things are recorded, but the transactions themselves that are recorded are created off-chain. And so we have to think, when we're thinking about financial contracts, we have to think not only about what happens on the chain, how the transactions are created, but also we have to think about wallets, the places that people store their digital assets, how they interact with the chain. So when we're thinking about contracts, we don't just think about what goes on chain, but we have to think about the off-chain components as well. I've said a bit about the fact that it's a distributed system, but again, that isn't really material for our design or our considerations. But we do have to think about incentivization, keeping the chain alive. And we have to think about similar things when we think about contracts. We need to ensure that contracts behave as they should and that they are, as it were, kept alive. But I just wanted to include this video so that any terminology I used was explained, but probably for many of you or most of you, what I've explained was something you were clear about already. So let's draw a close now and move on to the next topic.